This is the session 2 of Serverless Masterclass. We're planning to discuss how we can break monoliths to create serverless microservices and iterate faster. I am Shreyavadya Subramanian. I'm a developer advocate at Catalyst, and I'll be your trainer for the next 1 hour. So the agenda for today is to give you an introduction about what the Serverless Masterclass is and what to expect from it. So at the end of this hour, what would success criteria be for us? So what would we have learned? What would we hope to learn? And what we could do from then on? Then we can delve into 3 levels. Again, this session has been divided into 3 levels. You can look at this to say it's a rookie, ninja, and a maven level. But the idea is to say if you're a beginner, then we'll take you from 0 to where you need to get. Whereas if you're someone who's experienced, we would like to see your thoughts, your questions, and your inputs here, which is why we've structured this session into 3 discrete components. And after that, we have a couple of announcements regarding the features on the roadmap and upcoming events. So we'll share that with you as well. And we're excited to get started. So without any further ado, let's go ahead and look at what is the Serverless Masterclass. This session is intended to provide an introduction to serverless and possibilities in the world of serverless. So this is a session that is conducted to help you understand use cases that are possible with serverless that might not have struck you. So for example, an image processing pipeline or a microservice like the one we discussed today. So these are everyday use cases that we handle. However, we might not have thought of it in a serverless way. So the goal of this session is to help you understand serverless and how serverless can be used in everyday scenarios. And what can you expect from this session? So this session is structured around microservices. So there might be 2 key takeaways. One being, have you architected microservices already? So are we architecting and building microservices as a paradigm on its own? So every service that we build, are we thinking in terms of a microservice already? Is this something that you and your organization are following? That's something that you'll definitely be able to answer. The second thing we would like to help you answer is, going forward, would adopting a microservice paradigm be right for you and your organization? Again, there is no right and wrong when it comes to it, but the goal of this session is to help provide you with a framework of sorts to understand how to think about microservices and when to adopt or when to stay away from microservices. So with that, at the end of this session, I believe we will be asking you this question on what you think is right for your organization. So if you have an answer for that, or if you have a way to think about that, then we believe this session would have been a success. So with that, let's get started. So as I mentioned, we have broken down the session into 3 parts. This is the Maven warrior level. This is like the 3rd level. So as you would have noticed here, we have 3 levels: rookie soldier, ninja warrior, and a Maven warrior. So this is the Maven level. If you're familiar with serverless or Catalyst, or if you've attended one of our previous sessions, then I would strongly recommend you give this a try. So what we're going to do is look at a use case right now that can be solved using serverless microservices on Catalyst. So the idea is for you to try to build or architect this solution before the end of the session. Again, if you're not familiar with microservices, we are going to look at the rookie level and we'll come to this level where we architect this. But if you're familiar with Catalyst already, do give this a try. And we have shout-outs, exciting shout-outs planned for people who get this right. So if you have serverless experience, or if you're familiar with Catalyst, I'll urge you to give this a try. So the Maven warriors on the meeting bridge, let's get started. So this is your problem statement. So again, we are looking for a high-level solution diagram to understand how you would build a serverless microservice that processes order information, estimates the vendor to pass an order to based on distance, cost, and quality preferences. So the process, again, this process is what we would follow, but we'll leave this process to you. So the goal is to create a solution architecture diagram that will help you build a serverless microservice that processes order information, estimates which vendor to pass an order to, and which vendor to process the payment. Rookie Warriors, this is a beginner's guide to microservices. So what is a microservice? There are multiple ways in which this concept has been defined. So there is this definition that it is a loosely coupled service-oriented architecture where small autonomous services work together. So the idea is that every component is independently deployable and speed and safety help you scale in harmony. So, but that is just a bunch of things that we've heard in the industry. What does this mean for you and your organization? Well, a, mo- a monolith is how usually applications were born. So previously, when an application was being created, the domains weren't well defined, so there were no clearly defined domains. For example, the payments module had dependencies with order processing. Similarly, inventory management had dependencies with returns module in an e-commerce application. So there was no clear defined boundaries for every component that belonged in a system. Well, the microservice model involves breaking this down into independent components that can be used separately from any application. So these microservices work independently and can be deployed separately, thus helping us innovate faster. As you can see in this example, there are multiple modules here, like the payments module, order processing module. Everything is tightly coupled in a monolith. Whereas with a microservice, we break it down to the independent services that can be scaled and deployed independently. As you can see, this has been used by multiple enterprise companies in order to scale faster. For example, an online streaming platform for sound applications, just for audio applications, was able to adopt a microservice model to ship applications faster and to maintain an edge. Similarly, there have been multiple cases with organizations like ThoughtWorks, Battery Ventures, commenting on how microservices has helped them power their innovation. So with that, what does the microservice model provide? Again, if you are new to microservices, this is going to be new for you, and we'll go take this step by step. If not, feel free to go ahead and design the microservice that we plan to discuss later. So migrating to a microservice model would involve a change in terms of the mindset, wherein the ownership of the independent components is assigned to smaller teams. This is a very important concept in an evolving team, because as the number of members in a team keep increasing, a monolith becomes very difficult to handle. And I'm not sure if any of you on this call have faced it. I hope this has not been an issue for you, but there have been cases where running on a monolith means the senior developer understands the code, they know the code, but when new people join in, they're afraid to touch the code. They do not know where the dependencies are, and a small change can lead to the failure of a critical feature. So microservice model leads to a change, a paradigm shift in terms of how we think of ownership, thus providing ownership of smaller components to smaller teams and empowering them. The microservice model also helps with scalability by allowing independent components to scale independently. So for example, the payments module might have to process only 3 requests at a time, whereas the order module should process 20 orders, 30 orders at a time. So this change in terms of scalability is difficult to handle in a monolith. Whereas with a microservice, it's as simple as it gets, because both the services are independent of each other and can scale independently. Dependency management also becomes easier with microservices. The dependencies are coupled into the same microservice, and multiple microservices are well defined with their respective dependencies. Agile processes, well, a microservice model helps you move towards an agile process where you have multiple teams working on smaller iterations and innovating faster. This is a paradigm shift compared to a monolith. So a monolith is where there is a lot of uncertainty and a lot of fear associated with operating on a monolith, whereas a microservice helps you break it down into smaller components and handle them with ease. So as mentioned in the title, microservices help you iterate faster. So how exactly do we achieve this? Well, a microservice helps provide a polyglot environment for your application. So if you're familiar with Catalyst, then we provide Java and Node.js environments. In these environments, it's possible to choose one function in Java and one in Node.js. This ability to work across programming languages can be very useful when architecting complex applications. Similarly, there is a need for applications to be comprehensive. So every microservice is comprehensive on its own, thus acting as an independent unit that can be built and deployed. So this again brings in the independent deployability factor, where the building and deploying of a microservice can be completely owned by a separate decoupled team. And when composed together, these work seamlessly. So although they are broken down into smaller components and ownership is distributed, together they work to achieve a singular function. And this helps bring in the composability factor. So organizational alignment and agility is what this leads to. So creating agile processes around microservice model is very easy, thus helping the organization iterate quicker with smaller microservices and deliver them faster. This will help bring in customer feedback and iterate again. Safety and security is also improved with microservices. So the independent deployability and independent manageability is very important. Independent deployability is where you've written the code and you need to push it to deployment. Whereas manageability comes in for readability of code, for making sure you're updating up the dependencies according to standards, and testability. So to run unit tests, so to run tests for each of the independent microservices becomes much easier and can be assigned to the smaller team who is in charge of the microservice. So for example, team A who developed the module will be able to give you a list of cases that can be tested within team A. Thus, the ownership of the complete microservice can stay within a team and helping easier operations. Thus, the testability and independent manageability, we've covered that. Efficiency and replaceability. So a microservice model is usually more efficient than a monolithic model. This is because of the independent scalability. So you can have one of the components provisioned with a higher memory, whereas you can have something provisioned with a lower memory. For example, I would probably do a compute intensive task with 256 MB of memory, whereas I would do something that doesn't require as much with the default memory of a Catalyst function. This again is like a thumb rule. If you have a compute intensive function, increasing the memory leads to better efficiency. And in a monolith, it's not clear about where you can increase this resource allocation for the overall performance. Whereas since a microservice breaks it down to the smallest components, this becomes easier. And replaceability, since the microservices are smaller decoupled components, if we want to plug in a different system, or if we want to integrate with a different system or replace an existing one, we can take it down to the smallest microservice and do this. There are multiple patterns that can be followed in order to do this. We'll discuss these patterns in detail in the upcoming slides. Scaling at runtime, this is again something we discussed, independent scaling and scaling when required using serverless microservices, and resilience. So the overall system in case of a monolith could fail, and failure of the orders module would lead to the failure of the payments module. Whereas with the microservice model, with the resilience that it provides, even if one of the components is not working, it's possible to make sure that the other components are perfectly fine. For example, something like a custom button, in case it's not working, well, that is not great for us and we will get that fixed. But in the meantime, every other functionality of that application is going to work as is. A quick recap of advantages. Advantages are the scalability of the microservices, the polyglot backends. With Catalyst, it can either be Java or Node.js. Immutability, asynchronous microservices. So we discussed asynchronous microservices and event-driven architectures in the previous session. If anyone wants to take a look, we'll make sure we share the link in chat. And again, microservices helps us with resilience and replace. So it's possible to store the event that leads to the execution of the microservice. Thereby, the event can be replayed at a later date in case there was a failure. So for example, if I am facing a 500 issue, I can just store that status along with the response message and replay that after a time interval, let's say 10 seconds or 20 seconds, depending on the requirement, I can replay that. So that brings us to the end of the basic session, which was related to microservices, monoliths, and why adopt a microservice paradigm. So in case you have any questions related to this, please keep them coming in the chat. We'll make sure we pick them up. And if not, we'll get started with the Rookie Warrior session. So this is a set of patterns to help you architect microservices. Microservices can be an overkill for extremely simple applications. And there needs to be a level of judgment where we say, this might be a good use case for a microservice, whereas this can run on a monolith for now. So that ability to choose the microservices is critical when we start out with an application or when we try to migrate. This reason of why we're shifting and what do we shift. So these are two critical questions for us to be answered. And these are questions that can be answered using these paradigms. So we've got like 3 types of patterns. So let's take a look at these patterns. But before we take a look at patterns, I think I wanted to give you an overview of the types of microservices. So there are pre-built and custom microservices. Pre-built microservices are microservices that are provided by Catalyst. Custom microservices are microservices that can be built by you. So pre-built microservices include AI-related microservices like sentiment analysis. So given a text, we'll be able to check if it's positive, negative, or neutral in terms of emotions, and we'll be able to share that in a JSON payload. We've used this in the past to create an API with Slack to create, to parse the messages on Slack and create tickets on Zendesk when required. Similarly, we've got keyword extraction, OCR, and these are cool features that can be accessed directly through the console. So all you would have to do is access console.catalyst.zoho.com or .in or .eu. And when you create a project, you'll be able to click on the ZR tab and look at all these features. You can upload a file, look at OCR. So everything is available to you on the click of a button. Again, 2 types of microservices, pre-built and custom. With custom microservices, you can bring your own code. You can choose an editor, Eclipse, Sublime, Atom, Visual Studio Code, your choice, and you'll be able to build on top of that. So it's possible to use open libraries and NPM packages. So for example, I've got the React Tinder card. This is a pre-built package that is available. It's an NPM package. So all you'd have to do is install React Tinder card in order to build a Tinder app. Again, if you've tried this in the past, we'd love to hear from you. If not, we will be sharing the architecture in our forum the upcoming week. So similarly, the confetti.js is again an NPM library that can be used to display confetti on your web client. These are things that may take a very long time for someone who's not familiar with front-end development. And even for the pros to get the positioning right, to get the colors right, it takes a long time. This can be done very easily through open libraries and NPM packages. The idea is to say, why reinvent the wheel? Why not build on top of what others have done? This is exactly what is possible through Catalyst and pre-built microservices, NPM packages, and open libraries. So confetti.js will help render this confetti. So you'll be able to configure the type of confetti, when it needs to fall, the frequency, and everything associated with it. Similarly, the React Tinder card will allow you to swipe left or right for Tinder in a Tinder application. So serverless microservices follow pay-per-use patterns. So in a month, if you do not use serverless microservices, you do not pay for them. So I can show you a demo of the Catalyst pricing calculator. I'll probably chalk this up for later because I'll have to change how I share my screen. But the idea is to say, in a month, You use Catalyst, you pay. You do not, then you don't have to pay. Not just that, we've got multiple debugging environments, starting with the local debugging that's completely free, development sandbox that's again free, and the production environment. In production, we provide up to 125 million invocations for free in the first year. So upon deployment of the first application, we provide 125 million free invocations. So types of patterns, there is the decomposition pattern, which is to say, I have a complete project. How do I decompose this into multiple possible microservices? Integration pattern to say, how do I integrate existing microservices in order to get to the solution? So this is like a top-down versus a bottom-up approach. And the database pattern is, of course, to say, how should a database be connected to a microservice? These are just 3 patterns that I've chosen for today. There are 5 or 6 patterns to explore in detail, and we'll make a detailed post on the forum with respect to every type of pattern. The idea is to show you a framework in terms of how you can think about these microservices so that you can explore and figure out if this is right for you and your organization. So there are 3 decomposition patterns that we'll be discussing today. We'll start with my favorite, the strangler pattern. The strangler pattern is usually used in a brownfield application. So an application that is existing, that has been implemented and deployed. So this application has been done as a monolith. They want to break to microservices. The idea of the strangler pattern is to say, let's isolate the least important or the least critical part of this monolith and build that as a microservice. So for example, in shopping or an e-commerce application, I would probably choose the wish list feature maybe, or something that is less critical in order to make that a microservice. However, it is never advisable to choose the critical portion. So if you're choosing something like the payments first to break away from the monolith, that goes away from the strangler pattern. The strangler pattern suggests choosing the least critical component that can be easily decoupled from the system to create a microservice. So this is with respect to strangler pattern, and enterprises or established apps usually follow the strangler pattern, where they try to move a smaller part of the application to a microservice model. Chances are serverless microservices might not be the best thing for your app. So if your app is running all the time, then serverless is not a good fit. If your app needs to run 24/7, chances are there is a different way of doing this. So what strangler pattern helps you do is minimize risk by moving the smallest possible component to a microservice. If that works, which it does once the use case is right, then you can migrate all other portions to microservices slowly. If it doesn't, then you can switch back to the monolith and you have minimized your risk. So this is with respect to the strangler pattern. The bulkhead pattern is intended to make sure that the system as such is reliable. So for example, if the reason this is called the bulkhead pattern is because of how a ship is designed. So the idea is to make sure the different partitions or the different microservices are scalable and they exist even in case of a failure of one microservice. So for example, if there's an issue with the order placing application, or if there is an issue with cash payments, then that shouldn't affect credit card payments. So one part of the system shouldn't affect another. Then we use the bulkhead pattern. So the bulkhead pattern provides a guideline in order to decompose in such a way that one microservice doesn't affect another. I know that this comes with a definition of a microservice to say we decompose them into independent components, but the bulkhead pattern goes ahead to say each partition that consists of a set of microservices are reliable and they can exist even in case of failure of the other. Then we've got the sidecar pattern. So let's take an example of logging. Logging is required in every application. So irrespective of which feature or which function you're building, you'd need logging. So if logging is added as a microservice, you'll be able to add this to any application. So this could mean a function or a class where you have defined how you would like to log entries in your application and access application logs. So the idea is to say, how would you create reusable components that can be used in other applications or other functionalities in the same application. So this is with respect to creating decomposition patterns. Integration patterns are used to help integrate multiple microservices to reach the solution. So API gateway pattern can be used to link multiple independent microservices. So API gateway is again something that's available with Catalyst. It acts as a proxy between the web client or your user layer and the backend layer. It takes care of routing, throttling, and it provides a single endpoint for communication. The aggregator pattern is again based on having a microservice that communicates with other smaller microservices, collects data, aggregates it, and shares it to the endpoint. The database patterns. So if you have an existing application, the idea is to break it down to microservices. There are two possible patterns: database per service or shared database pattern. So database per service is where we create a single database or a single table for every microservice. So a database that interacts only with that microservice. For example, the inventory management will have its own database, and that database belongs only to inventory management. We do not connect that to payments. We do not connect that to history. It belongs only to inventory management. That is database per service model. Whereas shared database pattern is where closely coupled microservices share a single instance of the database. So let's go ahead. The problem statement was to build a serverless microservices that processes order information, estimates which vendor to pass an order to based on distance, quality, and cost preferences, and sends it to the vendor to process payment. So the process, okay, let's skip the process. Let's just go into the considerations first to see what should we consider. When so the consideration first thing to see is, when do we consider switching to a microservice model? Does this require a microservice? So ideally, I would put it this way. I'm looking to solve a singular problem, which is to assign a vendor to a product purchase, depending on a range of factors. So I have a single operation to perform, and I can make sure that there are the dependencies are decoupled. So I can choose, this is a greenfield project, and I wish to choose the microservice model. When do we stop dividing into smaller microservices? So dividing into smaller and smaller microservices will create multiple decoupled microservices that do not work well with each other. That is not the end goal. So for us, at some point, we need to stop dividing into smaller microservices. For me, I stopped dividing it into smaller microservices or smaller components when I was able to find a logical connection. But more often than not, this comes with the use case. So everything that's coupled together becomes a microservice, and within a microservice we can keep dividing it into smaller. So there are well-defined domains, and we can divide it further if required. Distributed observability has been such a debated topic for such a long time because of how observability changes. So previously it was just searching across logs for an error, but right now it would have to be searched within the respective microservice. So for example, if there's an issue with the order microservice, it could be from the authentication microservice, or if there's an issue with payment, it could be from the cart microservice. So the chances are that the errors that we see aren't exactly from where they are thrown, but it is from a different microservice. So we need to have this observability across microservices in order to identify errors or in order to debug better. So the adoption of microservices in greenfield versus brownfield applications are very different. If it's a greenfield application, we look at the top-down approach to say, this is my solution. How do I break it down into microservices? Or these are the component microservices. How do I build this? Whereas in a brownfield application, we isolate the smallest possible component that can be built as a serverless microservice. We build that out, we deploy that, we see how that works for us, and then we iterate. This iteration could be switching back to a monolith or switching to a microservice for other components as well, depending on the experiment that we run. So this is how I would architect the solution. And again, there are components that have been assumed that I'm going to tell you about. But if this is something you've done, that's perfectly fine, because I'll start out with the assumptions. So my assumption is that my vendors can use platforms like email, WhatsApp, or messaging. This is my first assumption. My second assumption is that every customer will give me a minimum rating that is required to purchase a product. So for example, I will not purchase a watch, a smartwatch that has a rating below 3 stars. So this is a condition that will be given by me as well. This is my second assumption. And my third assumption is to say I'm going to run a check using latitude and longitude. This is how I'm going to store my address data. This is how I'm going to run the checks. Again, this is not the only way. This is not, there are multiple ways in which this is possible. This is the approach that I'm taking up. So I'll check if the product ID is valid. So the inputs that I'm going to get are the product ID and the minimum rating. So I get the product ID. I check if the product ID is valid. If it's valid, then I'm going to check the minimum rating that is required. Is it a valid ID? So for example, I might have a product ID that's structured to my brand's name. So for example, if I'm selling a Samsung phone, I might have something like SG followed by. So I'll do a regex check there, and then I'll check the minimum rating. So if the minimum rating is not an integer, or if it's not between the scale of 0 to 5, so that's a validation. I'm just making a sanity check there. I do this in a function, and then I will get the top 10 vendors arranged by cost. So if I do an order by query in my database, and I'll fetch the list of top 10 vendors for this product. So when I said top 10 vendors, what is it based on? Again, it's based on the cost of the product. So every vendor can list their own price. This is my third assumption. Every vendor lists their own price. So I'm going to sort them based on the cost, and I'm going to fetch the top 10 list. So I'm going to do a select query and an order by clause with limit of 10. So I've got 10 vendors, and I'm going to pass this back to my function. After this, I'm going to run a latitude longitude check in a different function or in the same function. It depends on the type of function I choose. But the idea is to run the latitude longitude check to identify top 3 vendors. So these top 3 vendors are the nearest vendors. So we mentioned 3 clauses: cost, quality, and the distance. So I'm going to check for the nearest vendor based on latitude and longitude. So whoever is the top 3 vendors out of the 10, I'll choose them, fetch their reviews, and share it across platforms. So the idea is to say, I've got this product ID and this minimum rating, so I'll assign it to this vendor. So I can say an Apple Watch is required, the product ID is something, and the minimum rating is 3. So for this, I have found out the nearest vendor who sells the lowest cost is from is vendor A, and I go to vendor A and say, vendor A might be connected with me on WhatsApp, they might be connected on mail, they might be connected on Twilio. So an interesting update, WhatsApp Cloud APIs are available in GA from last Friday, I guess. So the WhatsApp Cloud API was generally announced. So this implementation will be available in our forum next week. We urge you to give this a try. This is a very simple implementation of a backend microservice where we check a list of conditions and we pass that information to the respective vendor on the suitable channel. So vendor A might say, I need a message on WhatsApp. So we send them a WhatsApp message. Whereas for vendor B, we might send a message through Twilio, or we might send a mail. So that depends. But these are the 3 channels I chose. And it's possible to use AutoML to find correlation factors. So let's say this is in the scope of the entire application. You've got user demographics to say, my user from India is buying an Apple Watch. Whereas some user, so you'll be able to look across users for patterns. And you'll be able to run this across AutoML with classification. So you'll be able to do a label classification to see how many of them who are from you can classify the upcoming classes to say if they are from this region. Let's say they're from India and they have a minimum rating of 2. Chances are they'll get assigned to this vendor. So something like this can be done once we have enough data. Again, ideally, enough data depends on what you're looking to estimate. So somewhere around 1,000 to 10,000 rows is nice, but less than 1,000 rows is not recommendable. So the idea is to say, if we can automate this and get an algorithm to say, if this is the product ID and this is the minimum rating, this is the geography, then it goes here. So it's just to look for patterns and probably even patterns in sales. Once the sales is done, I'll make sure this example will be available in the forum next week. If you've tried it before us, you just have to leave us a message and we would love to hear your story. But the idea is to say, how do you use AutoML to find correlation factors? Thanks a lot for your time. I hope you have a great day. And leave us your feedback. Keep coming back to the Catalyst sessions. We have a lot of them planned. Thanks for your time.